Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on January 7th, 2026, just yesterday. It presents a new framework that allows AI agents to evolve a network of executable code skills, enabling them to unlock diamond tools in Minecraft with a 100% success rate, while cutting the required iterations in half compared to the previous best model. The paper is titled Evolving Programmatic Skill Networks, and as we'll see later, the results for long-term skill reuse and adaptation are really impressive. Figure 1 maps out the framework's full lifecycle. On the right, the hybrid planner and manager generate a plan, which is executed in the environment on the left. Crucially, the outcome drives learning. If a task fails, the top path routes to the skill optimizer to fix bugs using the reflect mechanism. If it succeeds, the bottom path triggers the online refactor to organize the code. Both processes update the central programmatic skill network, ensuring the agent continually improves. So moving to the results, Figure 2 tracks progress through the Minecraft technology tree. The vertical axis counts unlocked items, while the horizontal axis measures skill executions. The blue line represents PSN, and the orange line tracks the Voyager baseline. Notice that while both agents acquire basic tools quickly, the baseline plateaus significantly earlier. In contrast, the blue curve continues to climb, successfully unlocking high-tier items like diamond armor and obsidian, demonstrating the model's ability to handle increasingly complex dependencies. Table 1 breaks down the specific iteration counts required to unlock items in the Minecraft tech tree. The top section reveals that standard agents, like React and Reflection, completely fail to acquire even basic wooden tools. Moving to the middle rows, we see that while Voyager performs better, it hits a bottleneck at the diamond tool level, succeeding in only 1 out of 3 runs and taking over 100 iterations. In contrast, the bottom row shows that PSN unlocks the diamond tool in every single run. It does so in about 51 iterations, making it roughly twice as fast as the baseline while maintaining much higher reliability. Alright, beyond just speed, Figure 4 investigates stability by tracking the skill retention rate. The horizontal axis lists a sequence of tasks, starting with collecting wood and progressing to crafting an iron pickaxe. While the blue bars for PSN remain relatively high, indicating good memory, the orange bars for Voyager degrade rapidly on the right side, eventually hitting 0%. This drop reveals catastrophic forgetting, where learning new tasks causes the agent to lose the skills it mastered earlier. To understand how the system prevents this instability, Figure 5 isolates the impact of the maturity-aware gating mechanism. The chart plots the cumulative success rate over time, with the blue line representing the full PSN model and the orange line showing a version without this stabilization. You can see that without gating, the orange curve oscillates wildly. Every time a complex new task like smelting iron or crafting a diamond pickaxe appears, performance drops significantly because the agent overwrites its existing reliable skills. By contrast, the blue line stays high and stable, confirming that locking in mature skills is essential for learning deeply nested dependencies without regression. Well, having established stability, Figure 6 turns to efficiency by tracking the size of the skill library. The vertical axis counts the number of accumulated skills, while the horizontal axis marks the training iterations. Look at the dashed blue line at the top. This represents a version of PSN forced to create a new skill for every task, and the count simply skyrockets. In contrast, the solid blue line at the bottom shows the standard PSN model. It plateaus early, keeping the library compact even as it solves more tasks. This confirms that the agent is actively reusing and merging code, rather than just endlessly accumulating new scripts. Wrapping up, this paper demonstrates that treating skill libraries as evolving networks, rather than static lists, is crucial for open-ended learning. By mimicking neural network dynamics like backpropagation and layer freezing within symbolic code, PSN effectively solves the catastrophic forgetting problem that plagues other agents. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.